Physics, Newton's laws, P22D, apply Newton's first law of motion. Newton's first law of motion. Now what do we have here? We have a book that's sitting on a table, and we have a person that is lying on top of the water. So this, in both situations, we see that these objects, the person and the book, are not moving anywhere. So this is a situation when these objects are at rest. So Newton's first law of motion, the first part states that an object is at rest. That means it's not moving, velocity is zero, speed is zero, as long as the forces acting on it are balanced, they're equal. These equal forces will usually be force up equals force down, and force left equals force right. Now in this situation, as we can see from these two diagrams, we do not have force left and force right. That means we only have two forces acting. For the book, there is the weight going downwards, the normal force going upwards. They are exactly the same size. That means they are equal, they are balanced. The book is not going anywhere. Normal force from the surface, and the weight is the force due to the earth. The same thing here. A person lying on the water. Gravitational force pulling the person down. The same force in size. A buoyant force. That means an upthrust from the water is pushing the person up. So it means the earth is trying to pull the person in the water, but the water is trying to push the person out. At this moment they reached equilibrium, so this person is not moving anywhere. Another situation, the object will be at rest. Like for example here we see two people are trying to push the crate, two hands are trying to push the crate. And on the bottom diagram we have a force that's trying to push a box. And then there is friction against the force. But if we look at the size of the arrows, this size of the arrows, left equals right, left equals right. So an object is at rest as long as the forces acting on it are balanced. These equal forces will usually be force up equals force down. Do we have force up and down on these two diagrams? We do. We just didn't diagram them anymore. Because there is a box here, there must be a weight pushing down or pulling down. And then because it's sitting on the surface, in both situations they are sitting on surfaces, there must be a reaction force, there must be a normal force pushing up. But in this instance we also have forces pushing the left and right. If we look at the first diagram, we didn't have this situation, we only had like two forces going up and down. Here we have four forces. The up normal force, down weight. There is an applied force to the right, and there is friction to the left. In the bottom diagram, they are equal. That means balanced forces, the object is not going anywhere. And here we have two forces, left and right, again equal, the object is not going anywhere. The second part of Newton's first law of motion states that an object is moving with constant speed. That means its speed is not changing, steady speed, as long as the forces acting on it are balanced and equal. So we have two situations. We have the object is not moving, and the forces acting on it are two forces or four forces, or the object is moving, like we have here with the steady speed. In this situation, there must be the four forces acting on the object. So we'll have weight going down, we have normal force going up, and then we're going to have applied force to the right, and we're going to have friction to the left. Now these forces are balanced, so up it balances down, left balances right. How do I know this object is moving? Well, I don't really know if the object is moving or is at rest. In this situation, the exercise, the problem will probably state that an object is moving. So you will know, okay, the forces are balanced, but the object is moving, is not at rest. When you're in a plane, for example, or you're analyzing the speed of the plane, this plane can be moving. Well, obviously, if this plane is not on the ground, so the plane must be moving. But as we look at the arrows, all the arrows are equal. That means top, the lift equals the weight going down, so up equals down. Left, the thrust, equals right, the drag, so left equals right. This is the situation when the forces are balanced, and this is the situation when this plane will move with a constant speed. So as a revision, short revision, Newton's first law of motion, but forces are balanced, object has no acceleration, the object is either not moving like the book or is moving like this airplane, but in both situations the forces acting on the object are up and down, left and right, and are equal one with another.